I'd like to welcome everybody to the Terracotta webcast series. Today's episode, the big memory revolution in financial services. We'll be talking about how financial service firms, including large commercial banks, big investment institutions, and credit card payment processing companies are using big memory in-memory computing to drive exciting gains in their profitability and customer acquisition and application performance. My name is Jeff Lunsford. I'm the Sales Director for the Americas at Terracotta, and I'm joined by Karthik Larithraj, who manages our field engineering and consulting teams. Hello, Karthik.
Hi, Jeff.
Today we're going to run through a quick presentation that will highlight some of the challenges facing the financial industry, why many organizations are evaluating and moving forward with an in-memory data management strategy. We'll provide a brief overview of our solution, then we'll dive into some of our customer use cases, as well as spend some time answering your questions. As I stated earlier, my name is Jeff Lunsford. I've been with Terracotta for about 3 years. I've spent this time diligently helping our customers and some very large financial institutions solve speed, performance, and data consistency-related issues in their application development environments. Karthik, would you like to provide a quick intro?
Sure. Hi, everyone. I'm Karthik Larithraj. I'm the Director of Global Technical Services East. I've been with Terracotta for around 2 years now, and I help manage pre-sales and post-sales. And performance and scale are one of my pet peeves, which is why I love the job.
So today, the financial services organizations are dealing with a variety of big data challenges. The explosion of data is creating business problems that the prevailing technologies cannot address effectively. Some of the areas where we're seeing organizations have significant issues are trade and transaction processing, risk mitigation, fraud detection, customer service applications, and portfolio evaluation, as well as compliance-mandated reporting. The bottom line is your organization needs to process more data faster. And the faster you have access to these large amounts of business-critical data, the better the decisions your team can make, and the better they will be. The in-memory revolution has begun, and to meet these requirements and create competitive advantage, the enterprise is moving significant amounts of data into memory, giving their applications microsecond access to business-critical data. This phenomenon has been facilitated by the significant drop in the price of RAM. Major manufacturers are now producing servers with hundreds of gigabytes, even multi-terabytes of RAM on a single commodity box. And because our solution provides a much more efficient and effective way to utilize this capacity, our customers are at the forefront of the in-memory data revolution. They are creating large in-memory data stores, delivering their business real-time access to high volumes of data, opening the door to solve business problems that just weren't possible before. So now, memory has become the new disk, and disk has become the new tape. Let me quickly provide a couple of examples of how our customers have changed their business using our technology. So one of our customers was able to cut fraud detection times from 45 minutes to less than 4 seconds, while still processing hundreds of millions of transactions per day. Can you imagine their return on investment? Another customer was able to increase their customer service transaction throughput by 100x without significant changes to their application environment or a forklift upgrade to their infrastructure. Another customer was able to reduce the number of transactions on their mainframe by 80%. This decreased the overall number of MIPS and in turn provided millions of dollars per year of savings for this company. You might not know it, but you're using Terracotta everywhere. When you swipe your credit card, you send your buddy some money via an online service, if you buy a ticket via one of those inexpensive travel sites, or you're making changes to your account, there's a great chance that you're using our technology. As we look at some of the strategic initiatives facing C-level IT executives today, I believe that in-memory, and more importantly, big memory, will be the core enablement technology, helping customers develop and deploy applications to the cloud, providing real-time answers to big data problems, a platform to help modernize legacy applications, and reduce our dependency on the database, making our applications much more scalable and elastic. So Karthik, I'm going to ask you to jump in and talk a little bit about where our solutions are being deployed in financial services, to also provide us with a quick overview of the big memory solution, and then deep dive into a number of customer use cases that you've personally worked on.
Sure, thanks, Jeff. So big memory itself has been deployed on 30% of Fortune 500 banks, and part of the reason is because it's very, very simple to use and very easy to deploy, and simple in terms of performance and scale. What works with 2 GB or 5 GB of data should also work with 4 terabytes, which should also work with 10 terabytes, right? The add-a-brick approach works really well with our Terracotta BigMemory product, and which is why most popular financial services company uses this. We are present in numerous use cases, right? Fraud detection for big data scale. That's a very common use case. Portfolio valuation. We have customers using us for collateral management, real-time transaction monitoring, payment systems. All of this work both for small-scale data, but also can scale up for terabyte-scale data. So the architecture behind big memory is to allow you to use all of your available RAM in your servers without any tuning. The architecture on the left is the traditional way of architecting big data solutions, right? So without big memory, you have multiple applications stacked next to each other, and we use all of the unused memory by simply adding a box next to each other and using up the commodity server. What big memory does for you is to scale up on the box, max out individual instances, use all the available RAM without virtualization, and having a predictable latency. The key thing is predictable, right? Every time you go and access the data, you want microsecond access. Even if it's a Thanksgiving Day, even if it's a New Year's Eve, or if it's 12 a.m. or 12 p.m. in the night. Every time you go and get the data without any GC pauses, you want to get predictable, very low latency to the data, and that's something that big memory provides you. So what big memory also does is 3 different things. You have scale continuum, density continuum, and availability continuum. Scale continuum because big memory can plug in along with any Java application and either scale up and give you the performance that you need, or it can be used as a remote server, and you can add big memory servers on the fly and scale out with servicing terabytes of data, right? So that's density continuum and scale continuum. We also have availability continuum. So if you have an outage and you lose an instance, you lose a data center, you still want no single points of failure, right? So big memory also provides you the availability continuum and a consistency guarantee that your data will always be consistent across the cluster and you will have no single points of failure. So with that, let's move over to 2 or 3 success stories in the financial services space. The first success story we're going to talk about is real-time fraud detection. So in this case, the company was having some issues with real-time fraud detection. The old system was in a batch mode. There were numerous sources of truth, if you will. The problem was meeting the SLAs because the data had to be collected from various sources of truth, and the end-to-end fraud detection time was not meeting the required SLAs. As a result, you are losing money to fraud, right? And that's obviously not an ideal situation. What we did was we installed big memory, and the big memory was used to store accounts at risk, fraud accounts. We had various transaction rules and models which your data had to be run through, and all of that information was stored in big memory, and you had predictable access, right? The SLA was 800 millisecond access end-to-end, and we were able to get this predictable access to this large amount of data. Without the existing infrastructure, it would have been impossible to meet this end-to-end SLA. What we also did was, in case during the end of the day, we actually had companies come back to settle the information that they already had in big memory. So you actually had settlement time that also needed 5 nines availability requirements, millisecond responses, and you wanted 5 nines of all your transactions to be completed in less than 800 milliseconds. And we were able to do that with the big memory system. Let's go on to the second use case, and this is another financial case which requires end-of-day trade reconciliation. So during the end-of-day trade reconciliation actually had to be done in a 4-hour window towards the later part of the day, and this actually required multiple sources of truth, right? You had accounts, trades, attributes, entity mappings from different systems to go and access the data and to do analytics with the data. What happened was they ran into a common problem with Java applications, which is GC tuning. GC is the bane of the Java world, right? And this caused them to restart their systems multiple times, and the application itself was unstable, and it was causing a loss of revenue. What big memory did was to reduce the heap and store all of the data in big memory, and to allow the big memory's search and analytics capabilities to be able to look for assets, look for trades, and to reconcile all of this within the SLA window that they had. So what we were able to do was achieve this both at a smaller level and then simply add a brick and process hundreds of GB of data by simply adding nodes next to each other. The last use case which we'll be covering is delivering collateral automation. So when banks lend to other banks, they actually have to keep a collateral to take the loan. There needs to be a third party who actually manages this collateral in what we call as a global long box. Now the collateral itself could be something like an IBM stock or gold or something of that sort, right? So what we need to do is that stock itself will vary because of market fluctuations. And you have to manage these equities. You actually have to allocate them appropriately. You have to price them. You have to go through a reallocation process in case the holdings change. There's recalls and various optimizations that need to take place. In a sense, it's a complete end-to-end financial system which requires multiple sources of truth. The problem which this company was having before the usage of big memory was everything was database bound, and this solution would not scale for them, right? You actually had multiple sources trying to process the same data, and you wanted one consistent way and a simple way to go and access this, right? A simple way that would work for 5 GB of data, but would also work for a terabyte of data with numerous accounts. What big memory provided them was an easy way to provide real-time access to this data, right? All the securities, collateral across multiple accounts were all kept in one place. We used a product called Quartz, which would enable the reallocation periodically depending on the user requirements. You would also have recalls and optimizations to be done from one place with big memory, and also allows you to add a brick and increase it from anywhere from 2 accounts to 2,000 accounts, right? It's going to be a one-way architecture where you can add a brick and scale up and then scale out. Big memory can also be integrated with Hadoop. Whenever you think of big data, Hadoop immediately comes to mind, right? Because Hadoop performs all of this at a very, very large scale. So what we have is a Hadoop connector where you can actually have Hadoop for historical data, for your entire data set would be in Hadoop, it would be sort of a level 2 of data, but real-time data which is not historical. Let's say 1 week worth of data would be accessed on an ongoing basis, and that window would continue to change, but 1 year's worth of data would be Hadoop in the Hadoop cluster. That sort of architecture can easily be done with us. Real-time access to data would be BigMemory, and historical data would be part of Hadoop. And the Hadoop cluster feeds the BigMemory cluster in a cyclic way, and you can actually have requests and real-time response. So you can have a MapReduce data in a MapReduce format being transferred to a real-time format for a continuous cycle, and that is something which is gaining a lot of traction as well. So with that, I would like to hand it back over to Jeff.
Thanks, Karthik. I appreciate that. I think one of the things that we're constantly asking our customers is, what could you do with instant access to all of your data? So I think this is a good time for us to jump in and answer some of the questions that have been asked during the presentation, make sure that we're able to address anything that you guys have questions about. We're going to have Cindy jump in here and read off some of the questions, and then Karthik and I will provide some answers. I think one of the things that was kind of notable on one of the slides that I saw, Karthik, was that, you know, when we're getting into some of these applications, we're usually dealing with some of the worst performing applications in the environment, and when they end up implementing our solution and getting through that process, it's usually the best performing application. So I thought that was fairly interesting.
That's correct, yeah.
Cindy?
The first one, let me get through some of these general questions. Typically, how long does it take to deploy BigMemory?
So typically we see customers go through a proof of concept. If we're on site with them, we can generally get done a number of use cases in a day to a couple of days at max. You know, if they're running through something where we're working with them remotely, it might take a few days more than that. But generally it's a fairly quick process. Majority of our customers are going to go live in production from development to deployment in under 90 days. Karthik, would that be consistent with what you've seen in the field?
Yes, it is, and I would like to add a little bit onto this. Usually, like you said, a lot of customers use our product even without knowing it, simply because we are embedded with most common products in the Java market, right? So usually it's just a few lines of config to make the change, but the end-to-end process, right from your development through the QA cycle through the production, takes a few weeks at max.
Yeah, that's very true. We are definitely embedded in a lot of different solutions.
Thanks, guys. I have another one that it looks like it's a question around the product line of BigMemory. I see BigMemory Go and Max on your site. What's the difference between those two products?
So BigMemory Go is a freemium solution. It's meant for standalone deployments and can be replicated, but is not distributed, so there's no consistency between the nodes, or the consistency is best effort. Karthik, would you like to add a little bit more to that?
No, I think that sounds accurate.
Okay, and then from a BigMemory Max perspective, you're introducing the Terracotta server array, and then you're adding in that consistency and scale across your multi-node application environment, so that you can keep all your data consistent within your application environment.
Okay, thanks, guys. Can BigMemory replicate data across data centers?
I'll take that one, and the answer is yes. Depending on where the data centers are, depending on the latency between them and the type of requirement, if you have an active data center where the requests are load balanced across data centers, or if you have an active and a DR center, and in cases you want to flip off a switch and move from one data center to the other, then we actually have a WAN module which provides that interaction as well.
Yeah, that's true, and we're seeing a lot of customers actually deploy this technology to keep consistency of data across data centers. It's a great technology, and it's very cost-effective.
I assume Terracotta does require writing to your API. In other words, I cannot take an existing database technology or custom application and port it without any code change, correct? That would be one for Karthik.
Correct. So if you're using most common J2E applications come embedded with EHCache or a variation of it. If you're using a persistence framework like Hibernate or OpenJPA or JPA in general, then enabling it would simply require a few lines of config change. There's no code changes required for that effort.
How is this different? How is BigMemory different from times 10?
I'll take that question. So
okay.
There's three fundamental differences between our technology and any other in-memory technology like times 10 or any other in-memory data grid. One of them is the ability to scale up using BigMemory. We have use cases who have we have 1 terabyte serviced in one node. No other technology in the market can do that. And the reason why we're able to do that with predictable latency is because of the BigMemory product. Right? We can go up as much as you want with minimum GC pauses. That's a huge differentiator between us and other in-memory data products. The second is the high availability, and that's having an active and a mirror which are always in sync and having no single points of failure. And the third, which is different from other in-memory data grids, is the simplicity. Our API is very, very ubiquitous, and we also have a Java standard way of accessing it. It's called JSR 107. We are instrumental in writing this API. Greg Luck, the founder of EHCache, was instrumental with this. And with this API, we have a one-way access to all the API behind the scenes, to all the access to BigMemory, both in your application and in your Terracotta server.
Right. I think times 10 is an in-memory database, and really when you look at BigMemory, we're enterprise in-memory data management, and we're actually giving you the data the way that your application is going to consume it.
Great. No, thank you guys. Thank you both for those answers. I think we have time for one more question, and like I said, if we do not get to your question, we will email you directly, and also in the follow-up email, we'll provide the slides presented here today to everyone who attended. So the last question is, how do you solve the GC or garbage collection pauses?
I'll take that up, and the answer to that is we store objects directly inside the RAM of your commodity server. We go outside of the heap, and we use something what is called as direct byte buffers. So essentially, we handle the data for you as opposed to Java itself handling the data. So because it's outside of the preview of Java, but still in memory, we get microsecond access to this with zero garbage collection for this time.
Yeah, I think that's important too, because you get consistency of data, but you also get consistency of application performance, right? And there's actually a great white paper on our website at terracotta.org where you can go in and see some performance tests that were run against an HP server. We did this in conjunction with HP, and it's I think we run 500 gigs, like maybe a terabyte and a half, and 2 terabytes on the same server, and you can go in and see the performance that we saw via that test. So Cindy, we appreciate your help in pushing out these questions to us. That's all the time we have today. If you didn't get your question answered, again, we'll follow up with you, or feel free to give me an email. My email address is Jeff, that's G-E-O-F-F, at terracottatech.com. We appreciate your time, and we hope you have a wonderful day, and we hope this was informative. Thank you.